Hi everyone, we're going to talk about the holes in a graph of a rational function and how to find them. These are the three problems I'm going to do. I'm also going to take these three problems and put them on separate videos to show you how to graph these more in detail with the hole. I went ahead and put the graphs of these on the video so you can see it, but this is just mainly about how to find the holes. So if we look at the first one, what we want to do is take r of x equals 8x squared plus 26x plus 15 over 2x squared minus x minus 15, and we want to factor this. So when you factor it, you're going to get 4x plus 3 times 2x plus 5 over 2x plus 5 times x minus 3. Now, this can be reduced because you can cross these two out to 4x plus 3 over x minus 3. That means we have a hole at what we canceled out. So you set this factor that we canceled to 0, and you subtract the 5. So we have a hole where x is negative 5/2. Now, we're going to plug in the negative 5/2 into our reduced equation. And that's going to give you, let's see, 14, this is a weird one, 14 over 11. It's a little bigger than 1. That would be your hole. Okay? So that's how you find holes. Now let's do the other two. They're a little simpler. And the other two are r of x equals x squared plus 5x plus 6 over x plus 3. And when you reduce it, you get x plus 2, x plus 3 times x plus 3 over x plus 3. Alright, so our reduced equation is going to be x plus 2 because we can cancel this out. Now, our hole, therefore, is going to happen at x is negative 3 because you just set this part to 0. And you plug in negative 3 back in, and you're going to get negative 1. So there's your hole. And when we graph this, this is just going to be a line. And the same thing is going to happen with the other one. I put r to the x equals x squared plus x minus 30 over x plus 6. And this reduces, or let's factor it, x plus 6 times x minus 5 over x plus 6. So this reduces to x minus 5. Now, this crosses out. And so our hole is going to occur at negative 6. You set this to 0. And when you plug in negative 6 here, you get negative 11. So you just plug in negative 6 minus 5. You're plugging it into that. Get negative 11. Okay? Here are the graphs. Here's the first one. The main thing you need to know about this one is when you factored this, you had, this was, at the bottom, this was 2x plus 5 times x minus 3. Now, if you looked at vertical asymptotes, you would have noticed that there should have been an asymptote at -5/2. But you can't have a hole and a vertical asymptote. So you can either have one or the other. We did have a vertical asymptote at x equals 3 here. Okay? But we didn't have one at x equals -1/2. Instead, we had a hole because it canceled out. So this is your graph, and this is what a hole would look like. This is also considered here points of discontinuity with the vertical asymptote, and this is the hole. So that's the difference. And then the next one is a line. Normally, we would have had a vertical asymptote here at x equals -3. But because this was a hole, instead, we don't have a vertical asymptote. And the same thing happened with this one. There's your hole. Okay? Now I'm going to take these same three equations and we're going to analyze the whole graph with domain and range and everything. Okay? Thank you. Have a nice day. Bye-bye.